Good afternoon. My name is Tim Hoheneder, and I'm a PhD student at the University of New Hampshire.
And I'm Jeremy Johnston. I'm a postdoc at the University of New Hampshire.
This afternoon, we're going to be coming to you talking about soil and air temperature relating to snow persistence in the McMurdo Dry Valleys of Antarctica. So for our research questions this afternoon, we're looking at, again, snow persistence and soil and air temperatures in McMurdo Dry Valleys of Antarctica. Our first research question is looking at the trends present in snow-covered areas, SCA, within the McMurdo Dry Valleys and how those proceed over time. As a secondary research question, we're also looking at the relationship between air and soil temperature across numerous sites in the McMurdo Dry Valleys. Coupling those two research questions together, we reach our final research question, our thesis of this, which is how the snow cover variability associate with air and soil temperature. So for our research sites, we picked 6 LTER climate monitoring sites across the McMurdo Dry Valleys. Given the persistence of snow cover in Antarctica, looking at snow research is historically undervalued in Antarctica. So we saw this as a big opportunity to begin to use some of those techniques that we've used at the University of New Hampshire and apply them to a new area, Antarctica. So for this, we're using MODIS-derived satellite data. So for this, we also see that in non-perennial snow-covered lands, effectively areas that don't have permanent snow cover on them, we're seeing about 5,000 kilometers of these non-perennial snow-covered sites. For air and surface soil temperature, we again use those 6 LTER climate monitoring sites that you can see present on the figure on your left-hand side. We analyze on a per-site basis from data ranging from the year 2000 to the present, and we aggregate on monthly average, knowing that most of this is daily data.
So to answer that first question, we took a look at the changes in the snow-covered area across the domain. What we found is that there wasn't a significant clear region-wide trend in the snow-covered area, but we did identify a few anomalously low snow years, particularly in 2002, 2009, 2011, and 2017. And this is all according to the MODIS-TERRA data. And what we also found is that based on this same data set, only 3 of the 6 sites that we were looking at with soil and air temperature data actually appeared to have snow on-off cycling that was occurring regularly on an interannual basis. And so we looked at those 3 sites that are circled here in red. So the last thing that we did here to quickly touch on is understanding that most of these locations actually seem to have a decrease in the amount of the snow off duration. So that means that there was actually snow cover tended to be more persistent in the recent 10-year period as opposed to the preceding one. And this was most pronounced at the MISM site.
Delving into those air and soil temperature trends, in the upper figure, you'll see your air temperature. In the bottom figure, you'll see your soil temperature. In this, obviously, we're not seeing any evident long-term trend to either, while there is interannual variability present in both soil and air temperature. We're not seeing that really change in a long-term sense. Additionally, we're seeing a strong geographic coupling of these variables. For example, the research station that's represented by the pink line in that top average air temperature figure is going to be that same pink line in the bottom of the soil temperature figure. Going a step further, beginning to couple these and looking at the relationship between soil and air temperatures exclusively, we see that there's a very high correlation. We found an R-squared approaching 1, which is, of course, a very, very high correlation here. And we're seeing this across almost all sites as well.
And so while they are highly correlated, we notice that there's a clear dependency on this relationship on the snow cover persistence as well. And so what we notice in the red there is that during the warmer months, when there's less persistent snow cover and there's high levels of sunlight, we see that soil temperatures warm more than the air, as you might expect, by around 3 to 4 degrees. And then during the coldest months, we actually see not a whole lot of insulation provided by the snow cover, where maybe a degree or 2, but it tends to be very similar. And so during that cold period, the soil and air temperatures are, like I said, very similar. And so one last thing will be good to mention here is that obviously, with the solar illumination being low in the winter, some of these optical SCA detection methods, like using MODIS, are limited. And so that's one thing to keep in mind here.
Last of all, we just want to acknowledge contributions of those who we pulled research from, and also their work and effort in Antarctica as well. And lastly, Thank you for your time. If you have any questions about this presentation, please direct them towards me at my email address listed on the slide. Thank you.
We'll be happy to answer.